In this series of lessons, we are going to look at files, and we are going to learn how to read from files and write to files. And in particular, we are going to look at plain text files, which are some of the simplest types of files. So the first question is, what is a file? Now, if you have used a computer, it's very likely that you would have saved something as a file at some stage. Maybe you would have downloaded a file from the internet. So most people in this day and age are familiar with how files work. It's those things that sit on your desktop and clutter things up. They take up your space, and they give us headaches every now and then, like that. But they are a very useful thing, especially when you are a programmer. So the issue is you have written programs, and they were really good. They were very powerful. They could process tons of data, but they always started from square one every time you ran the program. In other words, you couldn't shut down your computer or restart the program, and you couldn't do things, or you couldn't pick up from where you left off. Now, this is a very serious issue for serious, or let's say substantial programs, because you might not be able to do everything each and every time. So what I mean is, if you are writing a report, or if you are doing something that's going to take more than one seating to complete, you need to be able to save your work, to put it in plain English. Now, this is not really an issue if you are writing an application that's like a calculator. A calculator doesn't really need to save much. I mean, it has an ongoing memory as long as the calculator's on, or as long as the calculator's on, it'll have something stored in its memory. We can manage with that. We don't need to start off, or we don't need to save data or anything like that with a basic calculator. So with more serious programs, you need to be able to what we call save the state of the program, or where it is right now, shut down the program, maybe shut down the computer, and then restart the program, and then open up a file or read data that we had saved before. So another hidden advantage, of course, is not hidden, it's just not less obvious, and that is you can copy files between computers. You can't really do that with your computer's RAM. You can't copy your RAM from one computer to another computer. At least it's not very straightforward. It's not that it can't be done, it's just not something we do. So, and even if you're going to do that, it's very likely that you might need to store it in a USB drive or some external storage device, and then again the files come into play. So files are really important, to to say the least. So the files, or you would have heard that there are lots of different types of files out there, especially when you're using the internet. They say, okay, you get image files, audio files, and I mean FILES, not the PHILES, audio files and image files, and lots of things like that. But as far as the computer goes, it doesn't really differentiate too much between these different meanings that matter to the end user. As far as the computer's hardware is concerned, they are all a series of bytes or characters. So this is not too different to how your computer stores information in its RAM or memory, the one that clears off when you turn the machine off. So that's your computer's primary memory, or the RAM as we normally call it. So everything is stored as a sequence of characters or bytes, and those are of course made up of ones and zeros if you look with a magnifying glass. And with the files, the difference is they don't, well, if you store them in your hard drive or some USB drive or some permanent storage device, it will not disappear off when you turn the machine off and turn it back on again. That file will be there. So again, apart from that, it doesn't really make a difference whether you're storing an image file or a picture file or an audio or a movie or a document or any other type of thing. So again, it comes down to the interpretation of the data that's stored. So that's why it says how we interpret the data is what's going to make a difference. So when you're a programmer, essentially there's like two different types of files. So at the hardware level, I said that it didn't matter. That's what I said just earlier. When you're a programmer, you are sort of in the middle. You are the middle person between the hardware and the end user. The end user gets to differentiate between images and pictures and all these different types of files. The hardware doesn't really care. You, the programmer, you are in the middle. So as far as the programmer is concerned, there are plain text files and there are binary files. So again, you can treat plain text files also as binary files. There's no issue in that. But there are times when we treat plain text files as a different type of file on its own because of the programming constructs, mechanisms that are available through most programming languages that cater to reading and writing to plain text files. They tend to be a lot friendlier than the binary file reading and writing. So what are plain text files? Let's have a look here. I have a very common program under Microsoft Windows, which is WordPad. And I have saved this document in three different formats. One is called the RTF format, which is the rich text format. This is also available under Mac OS. So if you use TextEdit under Mac and if you save, I think it defaults to the RTF format. So most people think, okay, so RTF is plain text because you have only written plain text in there, nothing else. So therefore it must be plain text. So I have also saved this file as a .txt format and a docx format. So the docx format is a typical Microsoft Windows format, Microsoft Office format. And what I'm going to do is I'm going to open this .txt file in a fancy editor called Notepad++. Although it's fancy, it's actually available to everyone to download. It's a free software. It's also used for programming. The good thing about Notepad++ is it shows everything the way it is. If you don't have Notepad++ and if you're on a Windows machine, you can even use the plain standard Notepad. That's also fine to have a look. So when you open a text document from Notepad++ or a plain text editor, you see it as it is. It's just plain text. Now let's open up the rich text format. I'm going to drag it and drop it, and suddenly you can see there's a lot of things in it in addition to the actual text, which was just hello there, right? So that's what I had in the plain text. The rich text format has a lot of other things. So these are basically tags saying various formatting things and what fonts to use and all kinds of different things in there. So it's sort of similar to HTML in a way. But anyway, let's take a look at the docx format. So suddenly it's the strangest thing, or the one that's most distant to the plain text format. The docx format, which is what we use under popular word processing applications like Microsoft Word and OpenOffice. So any substantial or any useful, proper word processor is capable of opening the docx format nowadays. So here we have junk, essentially. It doesn't look anything like what text looks like. So the RTF format was all right, not too bad. I mean, we could see that, okay, this kind of like a program essentially, except for this null bit or the null part that's right at the end. So what is this all about? Well, this is what we call a binary file. That's what we said, that there is the other type. So this has a sequence of bytes, and some of these things that look like three things now. This ETX is actually one thing, and EOT, DC4, NUL. So anything that's highlighted in black individually, that's one character or one byte. Sometimes there is no corresponding visual character to those bytes, so that's why the editor has chosen to show those instead. So this is not friendly, in other words, and this is what we call a binary file typically, because images and most images or audio, video, that sort of thing looks like this when you open them in a text editor. So we are only going to look at this type of file, which is the plain text file. They are a lot easier to read from and write to, and the way you do that is fairly similar to how you read from and write. When you deal with the screen, especially using the console area of Eclipse, it's quite similar to how you do it from there. So in this final slide for this lesson, it shows a plain text file. You can have multiple lines of text. So as I said, it's the most straightforward thing possible. You have, you can create it using most software. So if you were to create this thing, you could just copy that. I just copied it to the clipboard, and I pasted that, and if I were to replicate it exactly as it is in the on the slide, I will hit enter wherever it's needed, and then there's the plain text file. So it doesn't get any more straightforward than a plain text file. So when you write from your program to a plain text file, it will look like this when you open it through pretty much any editor. We don't want to deal with things like RTF or we don't really deal with RTF at most stages. You might learn about binary file writing and reading later on in different subjects, but at this stage, this is what we are interested in. So let's take a look at how we can do that in the next lesson.